Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. My goal here is to find the exceptional people in their field. I ask them questions maybe they haven't been asked before and get some really interesting insights on what they're doing and how that can help you and your family, your health, in your life, etc. So today we have Kevin Outterson. He has a JD, so he has, a law degree, but he's also a professor at Boston University, a scholar in health and disability law. We're going to be talking about the role of bacteria in viral pandemics, especially probably in light of COVID-19. And so that's what we're talking about. So, Professor, thanks for coming. How are you doing?
Doing great. I'm indoors and trying to keep all my appropriate social distance.
Okay, very good. Well, one thing that I've realized is, and it's no fault of their own, but some people confuse bacteria and viruses. Can you talk about that just very briefly? The differences. I know there are huge differences, and then we'll get into specifically what you're working on.
Yeah, people do get this confused. If you have a common cold, probably what you have is a virus. And generally, an antibiotic won't do anything good for you because they kill bacteria, not viruses. An antiviral for the virus. And even worse, it's not just that it's worthless for you, but taking an antibiotic when you have a cold could wipe out all of the healthy, friendly bacteria in your gut and actually harm you at the end of the day. So you need to know exactly what it is that's hurting you and have the drug that's targeted, for what it is that's giving you trouble.
Yeah, and I've heard until very recently, figuring out what bacteria or virus was affecting you was a really slow process. And so I guess doctors, clinicians would give you broad spectrum antibiotics without even knowing really what was going on because it was just a time lag, and people either demand some kind of medicine or they were acutely sick and something needed to be done quickly. Is that right?
Absolutely. And medicine calls that empiric therapy, which is giving somebody a drug, an antibiotic or an antiviral, based on their best clinical guess without having anything back from the microbiology lab yet as to what it is actually that's hurting the person. And you mentioned, COVID, coronavirus at the top. And, today, almost everyone in the United States and in China that we have information on at this point, here we are, we're talking today on March 27th. But as of now, most of the patients who are hospitalized with coronavirus are getting antibiotics, not because the doctors, are making a mistake, but because in addition to having the coronavirus, a lot of these hospitalized patients have other things too. They're getting secondary infections by other viruses and then also secondary infections with bacteria. And so even with what's happening all across the country and around the world, it's not a past tense, it's today that doctors are required, because they don't have enough diagnostics. We've heard this story with coronavirus, to give the exactly right targeted therapy quickly enough. Every clinician, they would love to have, the Star Trek tricorder device that could tell them immediately what it is that the patient has, and then they could give them something that was targeted.
Yeah, I didn't realize that. So since we have a microbiome, it's so pervasive and so necessary for our healthy functioning, what's that interaction look like? Do you think that the microbiome contributes to our overall immunity? And when we're attacked by a virus, for instance, like the coronavirus, what kind of interaction goes on between our normal microbes and the virus? Do you think there is an interaction, and how so?
I'm really not the expert to answer that question. I think, but broadly speaking, the microbiome is still a relatively unknown field. There's so much that we need to know. It'd be like landing on a new planet and thinking it was, bereft of life, but then finding out there's actually a complex ecosystem. And so, looking at our hands or our mouth or, inside of our bodies, we are constantly learning more about the complexity of the ecosystem within the thing that we call people, humans. It's actually more of a complex ecosystem than we ever thought. And so anytime that you perturb or put a shock to that system, you might have unanticipated results, both positive and negative. So I'll leave it at that. You'll need a natural microbiome expert to say something more specific.
Yeah, no problem. What is your role, especially with the current pandemic? What's your focus right now?
For the past 15 years, I've become, I guess, increasingly obsessed, I think is the right word, professionally, in my research on the way that the market for antibiotics is upside down. I've been working on that for a decade and a half, originally trying to understand why it was that patents weren't incentivizing antibiotics the same way that they worked great, or some people might say too well, for many other high-priced drugs in the system. And that work was academic in orientation. And 4 years ago, at the U.S. government put out a call for someone to create a new way to support the small companies that are doing this amazing research. I applied. I collaborated with Wellcome Trust, which is one of the world's largest charities based in London, to apply for this U.S. government grant and got it, which is the thing I lead today, the nonprofit CARB-X. This is kind of like an academic dream and a nightmare. It's like you've had all these ideas that you thought about and wrote about for years on how things should be fixed. Well, here's a $500 million in 5 years. We'd like you to see go. We'd like you to go try and do that. And so that's the challenge that we accepted, and that's what CARB-X has been hammering away at now for 3.5 years, almost 4 years.
But how do you narrow the scope so you can be effective? Are there certain conditions you're working on, or certain populations of people in certain countries? Like, what's your focus?
Yeah, the coronavirus was not our focus. We are exclusively bacteria, and we look at the bacteria that the U.S. CDC and the World Health Organization, they both put out lists of the bacteria that each of them thinks are the biggest risk to human health on the planet. And as you would imagine, the lists are substantially overlapping. There's a lot of things that are on both lists. And so anything that's on one of those two lists, it's fair game for CARB-X to find early research and to try to move it forward to the point where it's actually being tested significantly in people.
So who's on the top of that list? Which bacteria? Would we know the names?
People would know them. You might. Acinetobacter would be an example. This is one that became better known to Americans when veterans coming back from Iraq and Afghanistan who had been injured in shrapnel or improvised explosive devices, IEDs. Sometimes they would, many times they would have infections that come along with that because there's a lot of, the dirt and the metal and the rocks that were embedded in such an explosive, terrifying event, brought with it things that would infect the wound. And the U.S. government was seeing, Department of Defense was seeing a lot of Acinetobacter coming back as a result of that. Now, this is not the sort of thing that the average American working in their back garden is going to encounter. But it became a larger threat because of that. It's also a threat that now circulates in many hospitals in the United States. So broadly speaking, the highest concern for CARB-X will be those bacteria that you might call superbugs, but the bacteria that are the biggest problems for hospital infection control experts with their most critically ill patients in the hospital. Which is why this is also important for coronavirus or for COVID. The way that you get these superbugs is that you have a compromised immune system and you spend time in a hospital or hospital ICU. And especially if you have mechanical ventilation, if your lungs are failing and they have to put the tube down your throat and use a ventilator to help you breathe, which is exactly what is happening to the sickest people with coronavirus. They're in the hospital ICU, they're ventilated, and they are more vulnerable than almost anyone to these sorts of bacterial infections that can kill people.
What's weird is I just realized when people think of viruses, they think of infection. When people think of bacteria, I don't think they ever think of infection. They think like, okay, circumstances or environment cause someone to have a bacterial infection or problem, but I don't think anyone ever talks about bacteria that can spread either, I guess just due to conditions, but do they ever spread from person to person through contact, or is that just a rare event or not on anyone's radar?
They certainly spread through contact. There's E. coli bacteria would be an example of one that people are well aware that there's times in which you can't swim at the beach, maybe in the summer because there was a sewage release or something. That's a bacteria. And the concern is that people swimming would get it. Salmonella, which sometimes infects food products like chicken and occasionally milk and whatnot. That's a bacteria. It's a foodborne bacteria. And certainly there's outstanding data showing how these hospital-based superbugs spread. They can actually track it genomically. They can sequence the genome of a patient and then sequence the genomes of 4 or 5 other patients who also had the same type of bacteria, and then trace the lineage and actually understand whether it was, were these 5 patients, did they each bring it into the hospital, or did they transmit it to each other in the hospital? So it is transmissible, but most bacteria, our body has really dealt with them for a long time, and most healthy immune systems can appropriately respond. But whenever we do something that kind of disrupts our normal body, that's when we're more vulnerable. So anyone having cancer treatment, they suppress the immune system. Anyone having a transplant, you suppress the immune system. Anytime you cut the skin or do something invasive, so a cesarean section for childbirth, or a knee or a hip implant, for somebody who's getting older and their knees have given out, all those things elevate the risk of a bacterial infection, even if we don't, see many of them in the ordinary course, just as younger, healthier people without these, life events that would make you vulnerable.
So, yeah, I've actually read a report from the CDC that talked about hospital conditions, and I guess they had said the drains in hospitals, the sinks, the P-traps and toilets and things like that, you have a mixture of medication going down there and bacteria hanging out in there too. And that's like a big area where resistance occurs, and the bacteria then sometimes get aerosolized out of the drains and toilets and reinfect. I don't know if you've run across that or not, or if there's other hospital conditions that are more amenable.
Yeah, this is the number one safety feature in a patient room is a toilet lid. Because if you close the lid, then when that flush happens, especially if you're in a sort of, sometimes the flush at an institution will be more aggressive and fast, whereas at home it might just be your regular old tank and it still gurgles, but it's not quite as of a thrust of water. Without that lid closed down, you just sprayed droplets, and sometimes quite small droplets, and they fill the air. And there's awesome and terrifying studies in which they use high-speed photography and special lighting to catch and try to track how long those droplets remain in the air when you flush a toilet with the lid up. So that's why it's important to know that bacteria, if you're sick with something, whether it's bacterial or viral, in many cases it's excreted through your normal bodily functions. And so if you wanted to leave a gift for the next person to use the bathroom, a very dangerous gift, you flush the toilet without the lid put down. Now, there's a lot of places in the United States The toilets don't actually have lids. Most universities, many hospitals, no lid. It's a simple, inexpensive safety feature that, until these studies were done recently, people hadn't thought about it correctly. But you are right also about the drains. And there's some simple fixes to that as well. But just the next 6 inches into a drain, from the sink in a patient room, can have all sorts of things, microbes growing in it. There's something called a biofilm, which is a structure that bacteria build on which to grow. You can think of it as a slime sort of thing that the bacteria will it's better suited for them as an environment. It helps them to stay there as well. And when they tested what's in the sink drains at just average American hospitals, not nasty places, but good hospitals, it was shocking, and changes the way that people think about how they need to clean a room if there's contamination by a bacteria or a virus.
Well, I'm thinking now, especially in the current pandemic, about airport bathrooms and any public restroom. I know they're not used as much now if people are supposedly staying home, but I mean, they really need to be really completely redone. I'm imagining your typical airport bathroom. The ventilation is not great. The toilets are flushing constantly, especially with automatic flushers. So it's not even just one chance. Right, without lids. And the hand drying has gone much more predominantly to air dryers, which blow stuff all over the room. So I would think now public restrooms, they really need to be redone in light of all this, because they're probably huge sources of contamination and issues.
Yeah, I don't disagree. I'm not an expert on bathroom transmission, but you can wash your hands all you want, but if it's in the air and you breathe it in your mouth because there's suspended droplets, then washing your hands isn't going to help. So yeah, public bathrooms in many settings, but also the private bathrooms. So in institutions that where there's a bathroom that it's only one person at a time, but people share it, like an office setting or something. It essentially means that if one person gets something that can be aerosoled by the bathroom, then everyone who goes in that bathroom that day, could be exposed to it. And this is how colds circulate. The reason why most of us get 1 or 2 or 3 colds every winter is that we've picked up the virus from somebody in some setting. Somebody sneezed on something and we touched it and then picked up a pretzel and put that in our mouth, and we got enough virus to get a dose that was viable to give us a cold. That's how that happens. But it's one thing when it's just a seasonal cold. It's another one when it's the seasonal influenza. And it's a whole other story when it's SARS-2, the COVID-19.
So, again, what's the current thinking in the organizations that you work for? So they have certain bacteria that they're targeting that appear to be really bad actors. And then what about, again, like we've been discussing just now, methods of transmission? Have they identified linchpins? For instance, would it be good policy for, now or not now, for people when they use the bathroom to wear a mask when they use the bathroom, even if they only use it then? Is that a particularly hot spot of transmission, or are there other practices that wouldn't be invasive but that would help really slow the spread of certain pathogens?
No, I'm not an epidemiologist or an expert in these sort of transmission things. You should listen very carefully to the most scientific advice that you can get right now in the United States on how to protect yourself. And I'm at home, and and we're very careful at home, and we go out as little as possible, only when necessary, and maintain social distancing as much as possible. So I wouldn't dream of using a toilet outside of the house right now during COVID. Right? You stay home. Listen to the public health professionals. But your other part of the question was, what do we do? CARB-X is we're an accelerator. We're designed to find novel technology that applies to bacterial threats, and do something about it. Because, as of today, March, late March, I don't know when this will air, but as of today, 1,200 Americans have died of COVID-19. Of course, that number will go up. But as of today, each year in the United States, 33,000 die from drug-resistant bacteria, right? So, there are multiple problems going on here. And we are finding that a lot of the people that are dying from COVID-19 also have, bacterial and pneumonial secondary infections. So we need to do both. We need to do all of the above. And CARB-X is here to focus on the bacterial side. There's a lot of money right now from Congress and many other settings, other countries, trying to look for cures and diagnostics and prevention vaccines against coronavirus. We, can only hope that for great success in all three of those categories.
Okay. Any big ideas that are, being put forth right now in your organization that you think have promise that you can talk about?
Yeah, the thing I'm most excited about in CARB-X is the entirely new approaches. We've had many antibiotics that over the years from just the current research system in the U.S. and the world, we're very good at producing, the fourth or fifth or 10th version of a drug. So another fluoroquinolone or another cephalosporin or another, drug like a penicillin and whatnot. But what's harder to do, it's just harder, is to create an entirely new class of antibiotic, something that's never been used in people before. It has a very different chemical structure, attacks the bacteria in an entirely novel way. Because of resistance, we need these completely novel approaches. I was born in 1962. That is the date in which the last new class of antibiotics against the toughest type of bacteria, the gram-negatives. The last new class that was approved by the FDA, it was discovered in 1962, so my entire lifetime. Within CARB-X, we have more than a dozen projects, research teams, companies. Each of them has a new class against gram-negatives. Now, science is really difficult. Most of them will fail, and they know that. But if only one, or we could really celebrate it two, if a couple of these make it to FDA approval, it's the most significant innovation in this area in my entire lifetime. So it's important to swing for the fences for home runs, to get entirely new approaches against bacteria, because their power to adapt and to resist is remarkable. And so we can't just continue to do the same thing we've done in the past and think it's going to yield a different or better result.
Well, in the spirit of that, are you looking into phage therapy, bacteriophages?
Yeah, absolutely. We're in the process of evaluating a number of phage companies. We invited at an open round in which we accepted applications from anywhere in the world for what we called non-traditional antibacterial therapies. These would be things that have never been approved by the FDA before, so entirely novel approaches. So not even a new type of antibiotic, but something completely different. So bacteriophage is actually a virus that attacks bacteria. So it's using viruses against bacteria. And the really exceedingly clever part of it is that when these bacteriophages find the right bacteria, they're very targeted. They don't kill every bacteria, just the specific ones. So it has the potential to harm your microbiome a lot less and just kill the thing that you're worried about. It lands on that bacteria. It injects genetic material inside. It hijacks the machinery of the bacteria to produce, many, many copies of the bacteriophage itself. And then it lyses, it breaks the bacteria cell open, killing it. But then in the process of killing it, releasing, multitudes of new phages right in the spot where the first phage found the first bacteria. So, it's a remarkable, potential. And we've had many cases in the U.S., dozens of cases of people receiving phage therapy in the past couple of years on compassionate use or experimental basis with encouragement. But what we need now is a fully understood, scientifically rigorous process, and multiple companies are moving forward, and CARB-X is evaluating which of those that we plan to support.
What's the, if the FDA is the big barrier, what's their position? Are they amenable to these alternative therapies, or are they harder on them and more discriminatory versus other types of drugs out there?
FDA is not the big barrier. Science is the big barrier. Why would we want to load your body with viruses, unless we were sure that they were safe, they're not going to attack you, and that they're effective, that they're going to kill the bacteria that's causing you trouble. So, it's not the FDA is the problem. The FDA has actually been remarkable in the way that they've listened to companies and educated themselves and tried to be up to speed in this area. It's just science. We can't just put random things in people and hope it works. Do the double-blind, placebo-controlled, if possible, clinical trials, because you want to know that you're not hurting people and that you're actually helping them, right? Especially when you're putting something like a virus inside of people.
Well, right. I know FDA has their process, and I'm glad that they're, very accommodating. I know that, you're not just going to give someone anything, and they have their process, but their process is long and onerous, and probably rightly so. I just wonder what their position is with these kind of therapies. Is there any difference in their position or no?
So I don't know if you've read the book, The Perfect Predator. It's about, a patient who was dying of Acinetobacter, and his wife, who was also a PhD scientist, was able to collect companies who were doing bacteriophage research and to give it into him, and Tom survived as a result of the phage therapy with FDA approval. So the FDA has allowed the emergency use of phages in many cases, dozens of cases, and showing remarkable flexibility. But those were people that are on death's door. Many of them made remarkable turnarounds. And those anecdotal stories, because that's what they are, it's not pure science, it's anecdote, was enough to launch multiple companies that then went out and raised money so that they could do a proper scientific approach as opposed to, helping somebody who was on death's door. And so the companies that have been involved, that are involved today, many of them have experience in this field because the FDA showed the flexibility to allow them to try it on willing patients who were close to death.
Oh, that's great. That's excellent. So for CARB-X, anything you can talk about that you sense is coming soon that's maybe in clinical trials already, or that what's the first things you think are going to come out of the consortium, and when?
We do three things. We do vaccines and other prevention. We do diagnostics, and then therapeutics, things like antibiotics and phage therapy. I think that all three are important. The vaccine is what's going to eventually help the world recover from coronavirus. And so a vaccine against the types of bacteria that run rampant in nursing homes, or for patients that are about to be hospitalized, maybe somebody with a voluntary, outpatient procedure. A vaccine in those settings would be remarkable, would be really helpful. Diagnostics, I've already talked about the fact that, we don't give doctors and other clinicians enough information. They wish that they knew exactly what it was that was hurting the patient, and as quickly as possible. And it's been a struggle to get something that's fast, accurate, inexpensive, can be done as close to the patient as possible, and can both identify what it is that's hurting the patient and what drug would be necessary to resolve it. So you want to know both the name of the pathogen, but also whether it's resistant to antibiotics, and therefore which drug should be used. That's a tall order, but I'm telling you, whoever figures that out deserves a Nobel Prize in medicine, because it will greatly accelerate the correct and effective treatment for millions of patients around the world.
Well, very good. Well, what's the best way for people to find out more about CARB-X and the companies that are, that are working with it or within it?
CARB-X, carb-x.org, and on our website you'll see who our funders are, the governments and charities who fund us, as well as the companies that we support. And you can click on those company logos and get a sense of what type of project they're working on. We kind of, I want to say that, it's interesting to watch the coronavirus response and to see how many billions and now trillions of dollars are being poured into this response. Viruses are like that sometimes. You have to look at the last several U.S. government, emergency responses. Well, it's been this coronavirus and then Zika for a time, and then Ebola, and then also the original SARS. And all of these appeared, and because they're viral, they grow and spread rapidly, and it scares people, and appropriately so. And then we roll out billions of dollars and investment, but we don't actually invest in the long-term public health infrastructure as much as we should, because we should just know that we can't name what the next thing will be, but we should be ready for whatever it is. Whatever the name of the next virus is after COVID-19 SARS-2. But bacteria is a completely different story. This is like the slow-moving train wreck. We've been tracking for years the growth of drug-resistant bacteria in hospitals and in the community, and it continues to grow in the number of people it kills. CDC estimates 33,000 Americans this last year from drug-resistant bacterial infections. Globally, the number is over 700,000. Now, these are big numbers, but it doesn't happen in a flashy, TV-worthy people with face masks and jumpsuits sort of time. And so it doesn't get the appropriate level of attention and funding that it should. And so, I'm not taking anything away from SARS, COVID, what we're dealing with right now. All the responses are appropriate and then some. This is a very serious condition. But I'm just saying there's also another quieter, slower-moving train wreck, which is antibiotic resistance, drug-resistant infections. And we should also be paying some attention to that.
Yep, makes sense. Okay. Well, very good. Kevin, I appreciate you coming on the podcast, and the work you're doing is going to have tremendous influence on everyone and hopefully their health positively. So thank you for being here.
Grateful to have the time to talk with you.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.